1.2, Basics of Functions and Their Graphs. So we're talking about functions, which is a relation. A relation is a set of ordered pairs, and the first component of that ordered pair is the domain, and the second set in there is called the range. For us, when we usually talk about this, this is the x and this is the y. So usually the x values are the domain and the y values are the range. Obviously, we could have different variables, but that's what we're used to on the coordinate plane. So a function is a correspondence from a first set called the domain to the second set called the range, so that any element in the domain goes to exactly one element in the range. You cannot have an x value that goes to two different y values, or that won't make a function. Okay, so if you're given just ordered pairs, it's best to maybe just make a list of what are my domains, what are my ranges, okay? So my domain is going to be my x values, my range is my y values. So my first ordered pair is negative 5, 3. I get negative 5, 5, negative 3, 7, didn't write small enough, negative 1, 9. Okay, so what you always look for is, in my domain, do I have the same value repeated with same or different y values? Because I have different y values for the same x value here, I have to say this is not a function, okay? So each x value has to have one and only one y value to be a function. Okay, so checking the second set, I'm going to have my domain and I'm going to have my range. I have 10, 4, 8, 6, 6, 6, 4, 8, 2, 10. And I'm going to be honest, the fact that none of my domains repeat says I have to have a function here. And it doesn't matter that we see this repeat over in the range, because we are allowed to have that repeat at any time, but you just can't have a value repeat in the domain that has different values in the range. So this one is yes, a function. So remember, it's the x values that you don't want to repeat. That's the one that we want to watch. Okay, so x is what we call the independent variable, because we can choose anything inside of our domain to do that. So it's independent, we get to do the choosing, okay? Y is called the dependent because it depends on what you chose for your x. Once you find your x, you plug it in, and what number comes out is what ends up being our range, or our dependent variable, okay? So let's peek at a couple of these. When we check an equation for if it's a function or not, the key thing is we want to, it says determine whether each equation defines y as a function of x. It basically means solve for y, okay? And then you look at what is left in your equation and you say, when I plug in an x, can I get more than one y value? Okay, so first solve for y. So for number 3, that's a pretty simple thing. We subtract the x squared, we get y equals negative x squared equals, or not equals, sorry, my equal's already there, plus 25. So you basically just ask yourself, once you get this equation, if I plug in an x value, will I get more than one y value? Well, if I plug in like 7, I'm going to get negative 49 plus 25, I get one value. There's no way I can get two values. No matter which value I plug in, I'm always going to get one y value to go with it. So this one is yes, it's a function. I feel sorry for anybody that might be trying to watch this without turning on the sound, because they have no idea why I just said that or not. But anyways, if it's you, you're not hearing me anyway, so I guess I'm not offending you. All right, number 4, I want y by itself. So first I'm going to subtract x. I get y squared equals negative x plus 27. Now I'm going to take the square root. So I get y equals plus or minus the square root of negative x plus 27. All right, obviously here I'm going to need to plug in values smaller than 27, right? I can choose any x values. So there's a limit there on my domain, but I still get to choose a lot of different values. So let's say I plug in, I don't know, negative 2. Or I shouldn't say negative 2. How about I plug in 2, okay? I get negative 2 plus 27 is 25. The square root of 25? Well, I kind of gave you a big hint when I wrote this. I get plus or minus 5 when I take the square root of 25. Because of that, I plugged in one x and got two y values. That is not going to be a function. So this is not a function, okay? And yes, we do deal with square root functions, But if you ever look at them closely, they usually give you a limit on the domain when you start with it, because you know that you won't have a function otherwise. So we can make a function out of a square root equation, but there's just a very limited domain. All right, for for number 5 here, we want to get y by itself. Currently there's 2 y's. How do I change 2 y's and get it down to 1 y? I factor. So I factor out that GCF of y, gives me x plus 2 equals 1. Now that I want y by itself, I'm going to divide by that x plus 2 because it's being multiplied. I get y equals 1 over x plus 2. Now the question is if I plug in an x value, will I get more than one y value? That's the question we're answering when we're checking for a function. So if I plug in 3, I get 1 over 5. I don't get any other options. I get 1 over 5. So it doesn't matter what x value I choose, unless it's -2, because that's a no-no. But every other thing, what I will get 1 and only one value. So because of that, this is yes, a function. And for all those inquiring minds, it says, what does that graph look like? Do you remember these things? An L in the corner and an L in this corner, something to that effect. That's what that graph would look like. So remember, there's like that little line at -2, which of course my graph doesn't even represent that, but that's a side point. We will get into those this year. We'll have fun with those eventually. All right. F of x, writing something in function notation. F of x or f at x, okay, it's your choice, but what you want to call that, it means the value of the function at that number x. So what we need to remember is whatever is in here in the x, that's the value we plug in to replace our x's with, and then we solve from there. So another thing we need to make sure we remember here is f of x, the whole thing, whatever it is our y value, okay? So when I say on number 6 that I want to find h of 3, what I'm doing is I'm trying to find the y value when I plug 3 in for x, okay? So when I see 3 in this x spot, everywhere I saw an x needs to have a 3. So I get 3 cubed minus 3 plus 1. Every time I saw an x, I needed to replace it with a 3. So 3 cubed is 27 minus 3 plus 1. Finish out the math here. 27 minus 3 is 24 plus 1 makes 25. So h of 3, or I could even say y, when x is 3, is 25. Okay, next one I get is x at negative x, okay? Or I'm sorry, h at negative x. So that means I'm plugging in for everywhere I see an x, I'm plugging in negative x. So I see negative x cubed minus negative x plus 1. So negative x cubed is negative x cubed because 3 negatives make a negative. Negative times minus the negative x will become plus x plus 1. Nothing more I can simplify, so that is my h of negative x. And this is something we're going to use a lot when we are checking for inverses and such. Okay, so no, not at all. This is what we're going to use a lot when we check for even and odd functions. And that's a lesson coming up. We'll get there. But just know that it seems silly to just do it, but we actually do this quite frequently in PreCalc. Okay. H of x plus 2. Okay. Here we have an expression. So that says everywhere I see x in my equation, I'm putting in x plus 2. So x plus 2 cubed. Wow, couldn't do that nice, could I? Minus x plus 2 plus 1. All right, I'm going to need some extra space here. I'm just going to come over here and do my x plus 2 cubed. Okay, do you remember that's the first term cubed plus 3 times my second, or my first time squared times my second, plus 3 times my first term times my second one squared, plus my last one cubed. Okay, so it looks like I get x cubed plus x squared with a 6 in front of it. Over here I get 4 times 3, which is 12 with an x, and then 8. Okay, so I get x cubed plus 6x squared plus 12x plus 8, and of course I'm running out of room. That negative is going to distribute to both of these, so I get negative x minus 2 plus 1. All right, joining my like terms. X cubed plus 6x squared, nothing goes with those. 12x minus x is plus 11x. And 8 minus 2 plus 1 is 7. All right, and that is what is equivalent, see if I can fit it in here, h of x plus 2. Okay? So whatever's in there, plug it in for every x you see and do the intended operation. So graphing a function, that's just showing where those ordered pairs are going. We did this basically in 1.1 as well. This time, though, it wants us to graph the parent function and then graph one of a transformed function and see what's happening beside it, okay? Actually, I'm getting ahead of it. They're not calling it parent function today, but that's basically what we're doing. So I'm going to start with our first function, what I would call the parent function, f of x equals x squared. Okay, so I'm going to make my t-chart. Okay, and just so you know, this is my f of x over here, or my y, whichever way you want to see it. And they did tell us here to go between negative 2 and 2. Negative 2, negative 1, 0, 1, and 2. All right, so I am plugging into that x squared. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So I'm going to graph this first function. So negative 2, 1, 2, 3, 4. Negative 1, 1. 0, 0, 1, 1, 2, 4. And I know that I can put arrows on because that's going on and on forever. Okay, so that's my f of x. All right, changing colors here so we can see the difference. Now I'm going to do g of x, which is x squared minus 2. So it should still be a parabola, but of course it's going to change slightly. This is my g of x or my y. Again, I'm going through the negative 2 to 2's. Negative 2 squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. 0 squared is 0, minus 2 is negative 2. 1 squared is 1, minus 2 is negative 1. And 2 squared is 4, minus 2 is 2. So negative 2, 2. Negative 1, negative 1, and 0, negative 2, 1, negative 1, and 2, 2. And I get this graph here, and that bottom one is my g of x. Okay. It does say once you've obtained your graphs, describe how the graph of g is related to the graph of f. Well, it looks like g, in real simple terms, we could say it went 2 units down. Okay, and just to throw kind of one of those words in here, so g of x was translated, okay, if you remember that, meaning just to slide it down a graph. Translated probably is what I want instead of translating. Don't want us to think we're doing any Spanish here. Translated 2 units down, so it slid down the graph. Okay. Go into number 8 here. We're going to go back, and again, I'm going to do the first one in black because that's what I would normally call my parent function. We just talked about this on the last page where I said the square root functions. Notice on this that it gives us my domain here, okay? Now, it's telling us what to use, but it doesn't tell us that we're limited on our domain. It's just saying use these 4. So 0, 1, 4, 9. And hopefully you can quickly see why they chose to tell us to do this, right? Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. They gave us values that'll give us decent numbers that we don't have to try to graph decimals. So 0, 0, 1, 1, 4, 2, and 9, 3. Only I would make a graph that had 11 spots so that you couldn't easily just go one line in. All right, it starts at 0 and it goes to the right. Just so we know, that domain would have a limit as well. We could only go 0 and then to the right. I don't want an arrow to the left at all, okay? Let's change colors on this and graph the second one, g of x. This time g of x is the square root of x minus 1. So notice they changed my x's again, 1, 2, 5, and 10. And we're doing g of x, which is my y. So 1 minus 1 is 0, square root of 0 is 0. 2 minus 1 is 1, square root of 1 is 1. 5 minus 1 is 4, square root of 4 is 2. And 10 minus 1 is 9, square root of 9 is 3. So I go to 1, 0, 2, 1, 5, 2, and 10, 3. And here's my new graph, and it goes right underneath my other one. And it says, what is it doing? And it looks like, again, it translated 1 to the right this time. Just shifted everything 1 unit right. Okay. How can we test a graph if we don't see the x and y values? How do we know if it's a function? And the easiest way to do this is the vertical line test. You just take your vertical line, you go across your graph, and you say, is this a function? Now, because I can't do this in person, you don't see it, basically I'm just taking my, I'm looking vertical, and I'm saying when I come down my vertical line test, do I ever touch more than one point at the same time? And for this first one, we definitely have to say it passes the test, right? There doesn't. So we're going to say, yes, this one's a function. Okay. On number 10, when I go to do my vertical line test, all of a sudden I'm like, wait a minute. When I do this, I'm touching 2 points at the same time, right? So this one is not a function. Okay. And the same thing on the last one, if I do a vertical line and I come down and I touch 2 at the same time, I have to say not a function. So that's just a quick, easy way to check a graph to see if it's a function or not. All right, next page. Lots of directions at the top here, just kind of reminding us of some of the things we have. So different information you can see when you look at a graph. And this is why it's so important that we're careful on the way we graph as well, because we are giving information when we graph, or when someone else looks at it, they're obtaining information. And if we don't follow the same rules, we're not giving the same type of information back and forth together. So a couple things we want to note here. If you have a closed dot, okay, that means this belongs to the graph, and yes, it's part of the solution to set, okay, if it's a closed dot. If it's an open dot, it does not belong to the graph because it goes all the way up to that point, but it doesn't include that value. And then obviously if we have an arrow, it just goes on and on forever, so we don't know where it stops or where it ends, okay? Domain, everything you see on the x-axis, all the x's we're allowed to use is probably the easiest way to think of a domain. Range is all the y values that were used when we did it. Remember, domain, we control when we choose it, unless there's a limit on the function. And then range is what results from after we graph it, okay? I can't stress this one enough, and this is something we have to do. When we are working here and giving answers, we want to use interval notation, okay? So keep in mind we're using interval notation when we give our answers on these, okay? Square brackets mean, yes, they include them. Parentheses means it goes up to that point but does not include that, okay? If we go to infinity and negative infinity, you have to use parentheses. All right, so a couple other rules here. Oops, sorry about that. Let me erase and move my page. As we go through the zeros of a function, okay? And this is important to note because this is kind of like the synonyms, different ways we can do this. Zeros of a function, also called x-intercepts, also called the roots, many, many different way, also called the solution, okay? So you have to remember that when I ask for zeros, there's different ways to think of it. They're all the same solution though, okay? The same answer. It's just how you think of it. Okay, what's important to know though is if it's written in function notation, if it says, what are the x values for f of x equals 0? Remember, what that's saying is when y equals 0, where is your x at? Okay, so it's where it touches the x-axis, okay? So the x-intercepts. To find the y-intercept, you're just looking for where it touches the y, or again, notice this interval or this function notation when, and remember what this is saying right here, when x equals 0, what number did you get? Okay? So one other thing I want to make sure you know, a function can have more than one x-intercept, but only touch the y one time, or it's not a function, okay? So remember that x-intercept could have a list of them, and we talked earlier about how you can make it just one value, or you can make it the value with 0 in an ordered pair. And again, it's up to you how you want to write it, as long as you clearly write it one way or the other. Okay, so let's lift this page just a bit more. Make it bigger, whatever I'm doing here, I'm not sure. Okay, we are going to just basically go through and say, what do we notice on these graphs now? Okay, so the first one, on this graph I have 4 things I want to find. We want to find the domain, and again, we're listing it in interval notation. For B, I want the range, and again, interval notation. For C, I want the x-intercept, and for D, I want the y-intercept. Okay, domain, interval notation. Where is the farthest left value here? So domain, the farthest left value is -2, and it was a closed circle, so it includes that, okay? Make sure you can see that. It includes that. And what's the farthest right value? Well, it looks like it's +1, but that's an open circle. It does not include it, so I make it -2, 1 for my domain. My range is one of those things, I'm looking at the y values, and I use the y values to give it. So what's the lowest y value I used? 1. And it does include it. There is a line there that goes through it, so it includes it. What's the highest y value I used? Well, it's up here at 5, and again, it was a closed circle, so it includes both the 1 and the 5. For the x-intercept, where does it cross the x-line? What point? It doesn't, so that's a none. The y-intercept, where does it cross the y at? Well, it looks like it crossed the y at the y value, which is 1. Okay? Again, if you want to write that as an ordered pair, you can. You don't have to, so it's kind of your choice how you want to write that one, okay? All right, on my next graph, I'm looking for the same values, so I'm going to do domain. I'm going to go range, both in interval notation. I'm going to go the x-intercept, and I'm going to go the y-intercept. Domain, what values of x are used? And I look from the far left first, because it's how I read across the graph, left to right. Well, because of this arrow right here, it's going to forever go into -infinity. So from -infinity is where I'm starting with, all the way over, and I stop right there at 4. -infinity is never included, so it's a parenthesis. 4 is included, so I get a bracket. For my range, which y values am I using? I start lowest all the way to highest. My lowest is stopping right there at that x-axis, so my lowest is 0, and it includes it. And then I go up, and I see the arrow will forever go up farther and farther and farther, so that's to +infinity. Never include an infinity or -infinity, so parentheses on that. X-intercept, where does it touch my x line? At 4. Where does it touch the y line for the y-intercept? At 2. Okay. One more page here, and just a little bit more basically of the same thing. I'm just going to give a few more answers to these. Okay, so you'll notice I'm given 5 answers now. Okay. All right, so domain again, range again, x-intercepts, y-intercepts, and this time the missing values. So domain on this one, which x's will be used from left to right? Well, I see an arrow to the left, I see an arrow to the right, so it looks like we're going to go from -infinity to infinity. Range is the y values, the up and down. The farthest down I see is -1, and it looks like it includes it, so a bracket. And as far as going up, I have arrows that are going to go forever, so that's going to go to +infinity, so I close it with a parenthesis. For the x-intercept, where did it cross my x line at? -1. My y-intercept, where did it cross the y at? +1. And D says now, they gave me these function values underneath. Where is it? F of -4. Remember, -4 is the x value. So I go to -4. Change color just so this stands out a little bit more. I go to -4, and I go until I find my y value. So I know my x is -4. What is my y right there? 3. So that finishes that out, okay? Then when I go to write my second one, I have f of 3. So again, f of 3, that 3 is my y, or I'm sorry, the 3 is my x value. So I go over where x equals 3, and I come to the graph until I find my y value. And if I look up there, it looks like that's going to equal 4. Okay, so same idea. Let's do it again over here. My A is going to be my domain, B is my range, C is my x-intercept, D is my y-intercept, and E is going to be my values. F of -2 and f of 2. Okay, so my domain, what x values are getting used? I see an arrow to the left, I see an arrow to the right, which means they're going to go on forever. So we're going between -infinity to infinity. My range, which y values will be used? Well, I definitely look like I'm plateauing here, and it doesn't look like it's slanting down at all. So it looks like the smallest y value used is 0, and it's included. Then it extends up and keeps going forever, so it looks like I would go to positive infinity. My x-intercept, little bit different for us because it looks like I have a lot of x-intercepts. So I'm going to write it in interval notation because there's no way I could possibly list every value. So it looks like for my x-intercepts, I go from -infinity all the way up to 0 because it's my x value there. Sorry, all the way up to 0. And it includes the 0, so then I put my bracket. My y-intercept, where's it cross my y line at? At 0. The origin is both the x and the y-intercept there. All right, now it asks me to check for two values, f of -2. So remember, -2 is my x value, so I go to -2. What is my y value at that time? Well, the y value is 0. F of 2, I go to f of 2. What is my y value there, if I can read through my scribbling over there? And it looks like I'm up at 4. Okay, so this is interpreting a graph. This is why it's important that our lines are straight, so someone can go to f of -3 or something and always know exactly where I'm at. If we freehand these sometimes, we may not be able to quickly be able to find the values there, okay? So once again, not a tough subject at all, not very hard. Practice as you need to on page 159. Let me know of any questions you might have.